Hello viewers, in this video I'd like to discuss about NAT. So what is NAT? NAT is called Network Address Translator and Translation, and Network Address Translation is called NAT. NAT converts a private IP address to a public IP address. You must know that private IP addresses are inside of internet and public IP address are generated in internet. So there are certain range of IP addresses that are fixed for private use and others are available publicly. And the private IP address are generally employed by the internet, and it is not possible to route to this IP address as they are not directly connected to the network. And this script is written by Prachi Agarwal. I'm just speaking because we had the same course with the same professor by Martin Karpas at Frankfurt University of Applied Science. And now here I would like to discuss about the how the total process of NAT is working. So you can see that so if the machine with IP address private IP address wants to if a machine in the private IP address wants to communicate to the internet they have to convert in a form which can be access to internet, and this can be done in two ways: by using application level gateway or by using NAT and using the packet filtering communication. In practical video I'd like to show you this second one, that is a NAT and applying packet filtering through that communication. But here we are going to discuss about only the um, theoretical aspect. So you can see that if we in this figure we have four machines A, B, C, and D, and A and B are inside of a private network, and they have uh, private IP addresses like A, B, and C. So and now let's say a private IP address wants to communicate a machine in D. Then there will be a NAT, NAT, N, which has a public address N and private address C. Now NAT is a binding here with AX. X is here the port number, so AX is binding to NZ. N is the public IP address with the Z translated port number. So you can see the source in the first box where we have a source AX and we are planning to destinate the packet to DY. Then NAT will translate the IP address of AX to source NZ, and this source NZ will then descend the packet to DY. So NAT translate the address according to dynamic NAT bindings, and again when we want to receive the packet from DY to AZ, the same procedure is happening here where you have sources DY and destination is NZ, and then NAT will be translate and then translate the IP address to NZ, and then it will be um, translate from public IP address to private address, that is from NZ to DY, and then it will be coming to private IP address destination AX. So this is how the process, and there are three types of NAT. One of the most important is called symmetric NAT, where IP source address, destination address, transport protocol, source port, destination port are all into taken into account. And the disadvantages is here that if one of the incoming is packet is blocked, if they block the entire incoming packets, so you cannot specify one, you have to block, it will be blocked all the packet. And we need a certain rule to let them in, and we can obtain it by using packet filtering. So make it simplify, we use this cone net. And cone net is especially um, used for IP address, and port numbers of external ports are not important here, and only the port number of internal system are to be considered. In that case, we have CoreNet, restricted CoreNet, and the third one is port restricted cone. So CoreNet is called anything coming to port. Let's see. No, it is like to make it more easy. So the CoreNet is saying that eh, anything coming to, suppose port Z on, this Z port is on the NAT machine here. Anything coming to port Z on NAT IP address N will be redirected to port AX on A. So anything coming from D, E, or some other place to coming to N on port Z, translated port, it will be redirected to AX. X is the port number of A. Now there are three restricted. Um, you can also say this A is called full cone net. Also, you can say cone net is also say, that means like um, if you have D, E, or F any machines from any port you are sending to NZ, that will be transferred to your AX port. So it is also called full cone. And there is called restricted cone net. In that case, you have to send only the D machine, means you have to have a receive connection from the same machine, but you can use variety of port numbers. So from D machine you can have XYZ, any port to it will receive to N, and then N will then translate and transfer to our desired destination AX. Now there is also another called port restricted cone. It is more restriction that you have to have from receive incoming connection only from the same port and same source. In that case, you can say that you allowed only from D, Y for particularly fixed, that you will accept only from incoming connection from only D, Y to AX port via LZ NAT. But if it is coming from EY or EW, it will not accept by the NAT. So that's all for the NAT. Thank you for watching this video. On next video, I will discuss something um, about this Linux net filter architecture.